I will fly over. Oh fuck, it will get recorded, right? I thought no one is there. But yeah, it will get recorded. I'm going back to 505. There's a 700 flight away. I'm sharing the link in groups so that people can join. Anyone's here? Can you people now hear me? Who is one viewer? Nice. Okay, we need at least like 3 viewers, I guess. Oh, 4 viewers. Damn. Fun zone is fine. Yesterday we had Vedant Pandey. We cannot have him today, I guess, right? Because he tried 2100 yesterday along with me. Haha. I can do that, but then I have already kept the title, right? I have already kept the title like solving each problem in a rating. I have to change the title. See, when this series ends, like I cannot keep on going, right? Maybe I will do more of random problems like atcoders or so. Okay, it wouldn't be too weird of a problem, I guess. Whatever the problem is, let me share screen. We will just try 2300s as this stream goes. I was watching this anime yesterday. Uh, yeah. Okay, I will read the problem for you if you want. Yesterday's atcoder. Haha. Yeah, I was watching yesterday. That. Mm, I can try reading atcoder. Today also there is, right. I should give it, I guess, but I'm thinking I should relax a bit. I don't know. Maybe I should give it. Yeah, I think I should give it. So we have to end stream by 5:30, 5:25, or 5:55 at least. Wait, when is this? Okay, Dan Gundes. Lost to me FNG. Is that what you are asking, Prismax? Yeah, okay, got it. Is it FNG? I didn't bath today. I just did face wash, I guess. Random gathering. I'll try to just read the problem and then maybe judge it a little bit and then stop. I won't solve them. I won't solve them much because uh, our stream we want to do today 2300. We are at 2300, right? Yeah. So we will try. We will solve one of these, and then we will solve 24, and then maybe that would be enough for today, I guess. So let's see. Let me read this problem. There are n plates arranged from left to right as plate 1, plate tops on plate n. Initially, plate I contains AI stones. We will perform m operations on these plates. In the ith operation, two integers L and R are given. The following operations are performed in order. Remove all stones from the these many plates starting from Li to Ri. Uniformly randomly choose any integer between Li and let it be x. Place all the removed stones on x. So it's like all the stones will come randomly onto something, it seems. For I equals to 1 to n, find the expected number modulo of stones placed on plate I when all m operations are completed. So yeah, we have plates, we have initial stones. What we do is randomly take this place here, 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 take this place randomly, take this place randomly. So that we keep on doing, and then finally we want expected number of stones everywhere, it seems. So this kind of problem, what does it need? It needs work, right? It just needs work because we want to find the expected number. So it's not like you have to get some great idea here to solve the problem, right? You should just do work. I don't know how to solve this yet, but yeah, all we should do is just work. We have to somehow solve the problem. Yeah, right. So uh yeah, I can change the title later if needed, like after that. So yeah, let's try to see what work we can do on here or so. Okay. uh Just somehow fly up. Okay, where are we? Yeah. So let's see if M is 1, just for no reason. Then what happens? All other plates will have same number of stones. Their expected number of stones is same number of stones, and these things will become total number of stones in that range by length of that range, because it could have been placed here, or it could have been placed here, or it could have been placed here, or it could have been placed here, and so on, right? So after an operation, what are the possibilities of the stones? After an operation, what are the possibilities of the stones? Like it could have either be 0 or it could have been x, 0 or x. For all those things, it could have been 0 or x. It would be x with some probability and 0 with some probability, right? So those are the probability distributions, let's say, after one operation. Now again, if you're doing some other operation, what would be the expected number of these things again? Okay, let's just look at one thing. Okay, let's just look at one thing, one index. Other things will keep changing because of their operations, and then when something comes in here, see, it depends on range that we select after first operation. Yeah. So what I'm trying to say is, if you just keep expected values, would that work? Like replace this with expected values and then keep doing that, will that give us the final expected values? Guys, like the video. 0 likes, some people will dislike too. So yeah, you guys should like the video, whoever those 10 viewers are. Dropping. I'll try to see if it's light. Only Prismax is active, I guess. uh, who is Snehal? I'm in Bangalore. Bangalore, near Cubbon Park, we can say. Cubbon Park, Orchard Street. Yeah, I know. I was just joking. You would be there, Arya. I know. Because there was only one, like I have told that. Yeah. So let's try to guess. Like, would that work? Maybe it wouldn't, but just guess. I know I'm guessing. So when we try to guess, we should be knowing that we are guessing. We have to have that clarity. Uh, if you replace values with if you replace AI with expected value of AI after an operation, will that work? Maybe or may not. It may not work because let's close that expectation thing. Uh, I will try to solve that too, Aish, because the stream anyway got drifted, right? It's not now 2300. So yeah, I will try to solve whatever that other thing too. So if you see this, that's one question we can think of. Can we do that? So let's say these are the four possibilities, is what they mean. Two, three, four, five, six. So we have to think logically too. I mean, in terms of proof also we can think, like, will that work? So you have replaced them with expected number of things, right? Now some other range has been chosen. So now sum this up and then again distribute them. uh, would that work? Let's just look that for two operations. Okay, for one operation it's true, that's simple. But if you see two operations that have some intersection, if you sum this up and then replace them with their average value, and then you sum this up and then you replace them with their average value, let's say we have It would work because it's either zero or some value, right? I think that's why it would work. Maybe. No, no, no. Yeah, it may work. Let's just see. At each moment we have, maybe it wouldn't work. If it works, it would be too simple of a problem, right? If that thing works, it would be too simple of a problem for this to be at f. Then people will just use segmentary or something, find the sum, replace, find the sum, replace, find the sum, replace. That would be too bad, right? It would be then just range update and then getting range sum. That's not a good problem. So if it is actually having something, then that's a good problem. If it's not just this thing, probably wrong. Probably wrong, but we can try to figure out using just trying to look at just two operations itself. We can understand the structure of the problem. So still the problem, what the problem demands is work. It doesn't demand some great logic from your side, I guess. I'm going back to find. Yeah, so let's try to look at just two operations, okay? The probability distributions of two operations. See, one thing is very clear. If we know finally for one index I, with what probability will it will take this value, with what probability it will finally have this value, with what probability it will finally have this value, and so on. That's the expected value of that thing, right? Because that's what expected value means. It can take this value with this probability, it can take this value with this probability, and so on. So we will finally have expected value of some of probabilities times the values. That would be that. So we should find those things for all of them. So if we have that initial distribution, can we get that? So we need final pi vi. Sorry, p j vj summation for index I. Okay, we need this finally. So this question was, if we have pi ji of all the previous things, can we get it finally? That was this question. So if you have summation of pi jis, if we replace summation of pi jis and then we use again the expected value is nothing but summation of pj vj, right? So this guess was, after this operation, when you do this operation, you will again take their sum and then replace them. Is that, will that work, is the question. It seems like it will work. Still it seems like it will work, right? For probability distributions, maybe it won't work. So let's look at two operations, okay? If it doesn't work also, we can solve the problem. I don't drink coffee much. When I go to office, I do drink, because what work can I do in office other than drinking coffee? Today I haven't drank coffee. I just woke up, I ate food, and then I came here. I woke up at 11. I gave one French test, I guess. Oh, I should not say such things on live, I guess. Yeah. So we have to try. We have to look at two problems. So Ari, no, who asked me this problem? Yeah, I listen to. It's like working while listening to music, I guess. Yeah, I do that. Studying, what study can I do? I'm too old. I'm not like young. Like I'm not young. I'm like 20. I'll turn 23. So, Prismax, have you tried analyzing two operations in the contest, two intersecting operations or not? You have tried, right? Okay. So let's see. Uh, After one operation, let's say this is one range. We have x with probability so we have at index I we have x with probability 1 by k, let's say k be the length, and 0 with probability 1 k minus 1 by k, and we have summation of these two be x by k, which is like expectation. So this is like pi xi. And so now let's say we are taking this thing, this operation, where we have here y as some other average, or let's say just all values, let them be same. And now we are taking this thing. Okay, what are all the different possibilities? If you just try to brute force, it can be either 0x, let's say this sum is y. Okay, just let's just say the sum is y, 0xy, or we'll just take one thing. So I'm just trying to analyze. Just I'm not thinking because I'm on stream. It's difficult to think. You guys try to do stream like me, then you'll realize. I'm just joking. Or x0y, or 0xy, or see, in future cases, it's not just 0 or x, because of this x, we can get x2 and then x3 and so on. So we'll have a bigger probability distribution, but we can surely not maintain all the distribution, right? It's probably something like this only. It's probably something like this. I wouldn't be surprised if it's just this too, because it's just a beginner contest, right? But then it would be too bad, right? Such a simple idea, just not even an idea, such a simple, maybe replace them with expected, and then again take range some range update. That seems too bad for a problem. So let's see this. This probability would be, uh, here the sum is x plus 5, and the probability is this being 0 and this being, let this be q. Okay, let this be pq, and again this is x plus y pq, and again this is x plus y qq. This is, sorry, yqq. This is x plus y pp. I'm not doing my best here because I wouldn't like to do such work in general. Like, I would like to think more, but for now I'm just giving this as a thing to do rather than getting scared of the problem. So if you look at these things, how does it come? Y comes outside. So y is just y into 1. If you sum them up, y into 1 plus, if you look at first x, what it is, x into, whenever first x is x, so whenever first x is 0, it has, let's look at that that value. Okay, let's look at that value. uh, if you look at that value, whenever it is 0 times, it is like 0 times q, because it's just linear, uh, plus x times q into p, depending on these things, this p, sorry, 0 times, let's fix this one being x. So if I take 1 and 4 together, sorry, if I try to look at 1 and 4, because this is fixed here, so if I try to look at 1 and 4 into p, so it is 0 times q plus x times p into p, plus again it would be the same, 0 times q plus x times p into q for other cases, because this is 0 0 into q. This will just add up to p plus q being 1, so it will just be this again, and which is nothing but expected value of that. So it looks like it works out, right? It looks like it works out. At least for two cases, it's working out. No, I'm not surprised why you're asking random questions like, do you drink coffee? Do you listen my music? I said 23. I cannot be 43, I guess, right? I would be balding if I am 43, but I have too much hair to bald. Uh, Large overlapping cases. It doesn't look so again, because let me tell you proof, because Here I'm proving it in a general way. I'm not adding them up. What I did was trying to see this and then get its probability distribution times remaining all the things sharing their different probabilities. They all sum up to 1. Then what we are left with, again the same thing. You see, I just didn't brute force them. I just wrote them in a way which is also proof for a bigger case. If you look at a bigger case, okay, where a range has pij comma xij be probability distribution. Let's just say capital Pi, capital Xi be the random variable at I, index I. Okay, we need expected value of sum of xi, right? So let's try to consider it is nothing but expected value of xi. So if you are trying to look at xi among all different possibilities, it will take the probability of xi being, so sum of expected value of I. So it's being too direct, isn't it? And if we have this already, so this is just the proof. I need not even go this much because we know already. So here what I'm trying to prove here is, so what I was doing here was E of x1 plus x2 equals to E of x1 plus E of x2 is what I was trying to prove here. And again here I thought of doing the same proof in a more general way. But if you see, what we want is E of expected value of sum, right? Some expected value of sum, right? Because after the operation what happens is uh, x, the final x after the operation will be sum with different probabilities, right? So E of x by k would be the final expected values. So if you see, this is just sum of E of x of y. So we need not maintain all the probability distribution, but if you just maintain expected value, we can just take sum and keep on proceeding. So if it's that easy problem, what should we do? NF operations is a wrong term, I guess, because we don't know how the operations can be, right? Operations can be just these things, can be just these things, can be just those things. They may intersect sometimes, they may not intersect sometimes, they may meet sometimes. We have to brute force. Your logic is good logic, but maybe that doesn't apply here because this is like very. So I think that would work maybe. I'll just implement it. Or should I verify here with this things? 0, 1, 1, 2. So initially it was 0, 1. If you do 1, 2, half, half. This is half, half. So what do we do? Should I try to write a brute force solution to verified samples and then go for, because we tried proving, but still we can write such solutions very quickly, right? Int n m scene n m int a of n scene a of I. Uh, I will write the power functions too because it's not that difficult to write them. It may help in ICPC. Like in ICPC, you have to type the whole code, right? Always. But you should not make mistakes like this. So yeah, now what should we do? I'll just write a brute force solution, okay? So we are trying to write an n squared solution to check if the solution is correct or not. There would have been at least one guy who might have tried brute force and see if it was right. Then he might have used segmentary. Uh, I'm going back to 505. That's a 7. We can even use for range sums and range updates. Maybe we can even use n root n, because if you have n root n segments, your range will fall in at max root n segments, right? Sorry, if you have root n segments, if you split the whole array into root n things, your range will fall on at max root n things. And then for this whole root n that fallen completely, you will just say, okay, this thing got updated to this. You can store that information. For this, you will go over root n things and then you will update. So even in that way, we can do without using segmentary. We can do n root n, n root n, n root n thing too. N root n plus m root n thing, or we can use segmentary, whatever will work. Anything will work in this problem, I guess. I'm going back to 515. Have you tried this one, Prismax in the contest? If it doesn't pass, we are wrong. If it passes, we are right. There are no test cases. I'm going back to 505. That song is difficult. I should not try that, I guess. I'll try some other song. Should I play some songs so that you guys in the background little bit, you guys won't be too bored? Uh, I have to play nice songs, not what I listen to in general, but nicer songs. Mm-hmm. This is not a nice song, but let it be. They will keep copyright after this. Okay, you have used this song. It will come here. What approach, bro? What approach? Like I don't get it. It is just a simple take. Instead of summations, keep expected values, right? I'm just a flower on a tree. Done. So you haven't done this thing. So you haven't done this thing. Why are you wasting us with such shitty problems, such easy problems? Prismax. Anyone would have tried this algorithm, right? Simple algorithm, like just store expected values after each object. So now what it is about. If you can do if you can do what? If you can do range operations, you're done now. Where are you? Yeah, it's fine. It's fine. I was just joking. What I mean was, you should have been able to do this in the contest because you don't get scared of problems. Just this thing seems working. Just such. I thought this is too bad. I thought it's wrong because how easy it is. Because of how easy it is. So now, if you have a segment tree that allows you to do range update and give you range sum, you're done. Because with range sum, you get with range sum you get x, and then you find x by k. With range update, you will replace that. So we can use segmentary and do that. Segmentary is not too difficult. Segmentary is a simple thing. Or let's use enroute logic. Okay. Yeah, segmentary concept is not too difficult, I guess. Like logic is not too difficult. You can just learn basic segmentary or segmentary lazy. That would help, I think. That's enough. Segmentary, the whole array will be divided into blocks. In the second layer, it has into two halves. In the third layer, we'll have like four halves, or like that we divide. So now, let's say you have that rooted tree. Okay, a whole array got divided into two things. This got divided into two things. Up to this one, we have this thing. Yeah, maybe like method, but you can try to listen whole. So we have all these segments, right? Try to focus on listen. Now if you take one range, any range from L to R, come from top, this top thing completely falls inside our range, right? So go below. Try to keep on going below and find and split this L to R into some segments. What happens is at each layer you will only have two things or four things at max, because if L and R has this completely and this completely, in the next step you will have only four things. What I mean is, no, I will tell you, I'll tell you people. So let's say L comma R, we are in the top layer, we are in the second layer, we have two things, right? So if you go down one more step, we may have four things falling in that. But if four things are falling on our L comma R, yeah, if four things fall on L comma R, what do we do? uh, the middle two things have been completely fallen. Now this goes again down. So we can split any L to R into disjoint segments that are there in the segment tree. Okay. So we can split any range into disjoint segments that are there in the segment tree, and these segments will be of uh, log n complexity, like I mean O of log n number of segments. We can split any L to R into that many segments in the tree. So now what do we do is, uh, we get answers of these log n segments already stored in the tree, so we get the answer total sum back. To update at each segment, we can keep, okay, this should be updated with value x, and then next time when we reach that and we go down, we can say, okay, all these are x, so all these are also should be x. That's lazy segmentary. So once this segment should be updated to x, you don't update all the below children segments. You will say this should be updated to x. You will store that information, and then when you again try to access it or its children, then you pass that information down. That, okay, all of this is x, so all of this is x. That's why it's called lazy propagation or lazy segmentary. Even if we use enroute, we do something like lazy. So if you do enroute, okay, enroute is not an enroute algorithm like I have mentioned. So the whole array is now divided into root n things. Okay, the whole array is divided into root n things. Now to update a range, what do we do? For the half intersecting root n segment, you will update each element individually. For the completely falling one, you say all of this must be changed to x. Bro, focus here. Okay, just okay. All of this must be updated to x. So we don't individually change all of them, but we store something like all of this must be updated to x. Such a thing is called lazy. Do you guys get what lazy is here? Prismax. Do you get what is lazy? What is that one? Exalcali. Mr. Raindrop falling away from me now. Dun, dun. So let's say this is our array. Okay. We divide the array into root n segments. Each length root n. Okay. So now let's say you have to update this whole range L to R. People can follow, right? What do? We update each of these elements. These root n elements we update. These root n elements we update. But we don't update these root n elements, but we say all of them must be changed to x. Okay. So for each segment, we have if all of them should be changed to x or not. But we just store this information that okay, all of them must be changed to x. But we don't do them now. But later, when we are trying to find some of this thing, then when we are at some segment, we will check if all of that should be changed to some x. Okay, if that should be changed, we change them now. So this is lazy. Instead of changing here everything to x, we are storing the information that okay, all of this must be changed, and then when we are trying to access from that segment for the first time, either here or somewhere, then we change that to x. Do you guys get? Yeah, root n segments. So this is the difference between segmentary and lazy segmentary too. Sometimes you have to update the whole range. What you do is you don't update. For this segment, you say all this segment should be updated. And when you access its children, only then you pass that information downward. So that's why it's lazy segmentary. I think you're not understanding the whole Prismax, but you get the idea, right? So even in this n root n thing, what we are doing is some lazy thing we are doing. Yeah, then that's even better, right? That's even better. So for this, we should be storing two information: the ranges sum, the segment sum we should be storing. If the segment should be updated, we should be storing, and all initial values we should be storing. We should be storing the segment sum. We should be storing if segment should be updated to x, we should be storing all individual values. So once this whole thing is covered, we directly get the segment sum. So if everything fits perfectly, we directly get sum. So in root n things, we can just get the sum. Is that fine? So I'll try to implement this just for no reason. Okay. So see, why am I trying to implement this? To show that if you do things systematically, if you can keep things well in your, if you see, I'm very clear what I'm going to store. I will store values, and I will store if it should be updated to x, and I will store their sum, segment sum. I will store these three things, and that's enough. So now it's not too complicated to implement this, right? Okay, we have these segments, we have those things, we have such things, we have some things, yeah, we have some things. So leave that. And let's see how simple the implementation can be, okay? Let's see how simple the implementation can be. So I will try to do this thing and this thing in routine things. This and this will become routine operations, right? So let's try to find our routine. So we have our routine. Okay. Now I think keeping capital makes nice. I don't know. Mm, because now we have our routine. Let's assume the whole array has been splitted. The whole array, any index, the whole array will be split into up to so on rn minus 1, and then uh, rn plus 1 up to so on 2 times rn minus 1. So we can just see these reminder things of rn segments. The final thing would be few things. Final thing would be just few things. Okay, it's just some reminder things, simple things. Now, so to get this segment, we can just do I by rn. So this segment is 0, right? This segment is 0. This segment is 1. See, I am not making videos on segmentary. I'm not making videos on en route and decomposition or some shit. Most algorithm is a bit different. I don't remember much, but I'm not making like en route and idea explaining, but I'm randomly explaining it in this stream. Even though, but this is not of a great idea, right? I mean, it's a original idea that we cannot come up with so easily in that way. But once you know that, okay, there is something called making that into root and things and then trying to update, then it's not difficult logic to understand that, okay, now a range falls on root and segments. We maintain sum of sum, comma, x per segment. Let me call it update per segment. So sum says sum of that segment. Update says the whole update must be replaced with this value. So if update is minus 1, no use. Else, what does it mean? Whole segment should be replaced with that value. Okay. So now let's go. Initially we have the segment, right? So initially, let's say we have sum of rn plus 1 is enough, but let's just have it till n. See, indices can go from 0, 1 up to so on, root n, root n. Because our root n is something, so final value of rn, we have rn times rn greater than or equals to n, right? So what would be rn by, sorry, n by rn? N by rn is our last index, right? N by rn is our last index. This 0 by rn is 0 index, so n by rn is our last index. So if we have n by rn plus 1, this size is enough. So let's just have that size. Also, update will be of same size. We can just keep n, but wantedly I'm keeping this because I can flex simple division logics to you people. I'm just doing that. Keeping n is also enough because we only use till here. We only ever encounter these indices, right? Or let me just make it like define segments, like number of segments. Or define int number of segments be, or ns be n by rn plus 1. At max, we'll have these many segments, right? Do we have viewers? Or everyone dropped because it's being too complicated for them? I'm using -1 because always stays from 0 to modulo always stays from 0 to positive, right? So I'm using -1. So now what will I do? I will update sum for our whole array. This is clear, right? Index I should go to I by Rn. Index I should go to I by Rn. So we got our sum. We got our initial data structure ready. So now what? Now what to do to get sum? What to do to get sum? What to do to get sum? We are at j equals to L, right? We are at j equals to L. So if j reminder Rn equals to 0, which means we are at the beginning of some segment. If so what will I do is, if j reminder Rn not equals to 0, let's say, means we are in between of some segment. Okay, what will I do is I will go over the whole thing until that happens. So what I can do is I can just write while j reminder Rn not equals to 0, what I can do, just get a of j. Okay, j plus plus. Now after this thing, we might have crossed our current segment has been crossed. Now we will be at where it is 0. Now we have to jump and keep going. Okay, are people there? You guys can see how I'm implementing. Madagudu, just joking. I just realized that image seg trees. Yes. So guys, I'm trying to do streams and practice, but you see, from 1 year I'm not practicing much. From 1 year I'm not practicing much. Before I used to. See, I used to. Initially I used to. But from 2024 I'm not practicing much. From 2025 I'm not practicing much. But now I'm doing more because of streams, I guess. But yeah, people, try to see and try to learn how I am. I will be IGM, bro. I'm not quitting till I'm not an IGM. Okay. See, I am staying in international master because I don't want to just touch GM. Once I become GM, I don't want to fall back. I want to stay GM and then become IGM. So I have to push. Yeah, I have to practice. I know that, but I have to correct my mistakes. If I can read test cases, that itself helps me a lot. Last contest, just test cases fucked me up. That's why today I tried focusing on test cases a bit. So I have to just make those rules properly. It's all about performing, I guess. Yeah, I don't need practice, bro. I follow systematic ways. I know how to solve problems. I graduated already, but please, what I'm trying to say here is see my implementation ways. This will just work, and then we will be at 0, and then let's not worry about update for now. Okay, and then while r greater than j plus Rn minus 1, so which is like our final value. So I need not even use this. I need not even use for loop. So instead of this, what I can do, okay, I can still use for loop. I need not even use for loop, but okay, let me remove for loop. Guys, see how I am implementing things. That's what I was trying to show you people, and then you're asking again random questions because I am making implementation at each step a bit better. So what I mean by implementations are simple is we can always make them nice and better. So while j plus r minus 1, now j reminder is 0, so this would be the last one, right? If that is less than r, we can have this whole segment. Now we are at a place where we must go till r. So we have our x already. See how simple implementations are. I think before starting implementation itself, we should have it very clearly. That's the right thing to do. But I'm just trying to show you people like implementations won't be too complex. See, remember this thing. Remember this thing. I cannot repeat that well. Implementations will only be as complex as the process is, because the processes go over this jump, go over this jump. So if that's the process, implementation cannot be go over the first thing, jump until you have, until it's totally covered. Once it's not totally covered, again go over individual things, done. So this is how we get the sum. Okay, and now we have to update things, right? So again we'll do the same thing. J equals to L. We have to update. So we have to update this whole thing. We have to update this whole thing. So here J doesn't matter, but update of J by Rn will be X. It won't be minus 1. It will be X. We have to update that to this. J plus equals to Rn. Let's also store the sum. But we have to be careful here. We don't know. Number of things in this segment may not be Rn. Number of things in this segment, if it is the last segment, it can have less than Rn things. Right? If it is the last segment, it can have less than Rn things. But if that happens, then also this will not hold true. Do you guys see how I'm again using a little bit of logic? See, it's all about mental work you can do. It's not like too complicated. It's not like you need great ideas. Yeah, we're trying to update. Don't type such big messages. I cannot read them. Do you get better at implementation just for the sake of getting better, or does it help boost contest performance? If you get better, it helps in your contest performance. But doesn't the third loop stop that? This one. See, these three things are getting sum. Initial partial segment, whole segments, keeping update aside. We are keeping update aside because it's a bit tough right now. And this is getting sum, updating things. So now we are updating this to X. And then this is true because this means the whole segment is covered, right? The whole segment is less than R, which says this is a whole segment. So this is fine. The sum is fine. And while, so here we can also make update of So one thing I can use is this loop and this loop is exactly fine. Same, exactly same, right? Nothing changes. They both are exactly same loops. So if I update here, I need not worry about the previous updates. So this will already be updated. So update of j can be, leave that, leave that. While j less than or equals to r, yeah, a of j equals to x, j plus plus. Done. Update is done. Now let's worry about how to handle if this should be updated. So if let's say if idx equals to j by rn, if update of idx not equals to -1, okay, let's just update the whole thing. K equals to idx times rn, or we have to worry about this thing, j less than n. This here we need not worry about n because it is bounded by r anyway. Also here we need not worry about n. Only here we have to worry about n. Because sometimes we may not reach the next reminder because we are at the end, right? So now let's just be this be the start index of this segment. If if I mean, this looks like it needs more logic. In contests, you guys need not do this. There will be some direct copy pasting things. I may do these things, but you guys need not because it may get tricky if you're not too careful. I'm not able to do it too careful because I'm in a stream. So what would I do now? I have to update this whole segment with X, right? Simple. K equals to start, K less than start, min of start plus rn comma n, K plus plus. I have to update this whole segment with a of k equals to x. And then I'll just set that as update has been done. I need not update again. J by rn, k by rn are all same things. Update has been done. So we have just updated that segment if it is not -1. Okay, here let's assume some will already take care of update. We need not do anything because it's the whole segment, right? We need not do anything. Even here, if update is there, we need not do this. 1 minute. I can keep this outside. Do we have viewers or is it getting too complicated? See, I'm trying to update here. That's like a bit lazy, but why complicate summation? Just keep it like that. So we if update of j by rn is equals to -1, then a of j. Else, let's do the updates in update part, right? Because anyway we are updating here the whole thing. So why do that updates here? Updating here is good, right? Because anyway the first segment, last segment has to be partially updated. So I'll handle updates here. So we are anyway doing updates here, right? So middle segments, this is fine. Update, we have to update all of them. Setting the sum, we're doing good. We should just worry about the last segment and the previous segment. If they have an update, we just have to worry about those things, right? If they have an update already, we just have to worry about those things. Also, we have to find some of those things properly because they are getting updated. So we just have to handle these two things, okay? So let's do that. If j reminder rn not equals to 0, that means we have some initial segment, okay? Let's update this whole segment, okay? This segment start is times rn, and this segment's let's say idx is, we have to update the whole segment, right? And then it's sum also we have to update. So see, if this is not there, if it is equals to -1, we need not do anything. We can just update the sum here. This sum will always stay positive because it already had this thing inside. So subtracting it and adding it, but we are taking modulo everywhere, right? So we have to be a bit careful because we're taking modulo, so that would not guarantee this. But things are long, long. Because things are long, long, This will work, I guess. What is even the question? Wait, we have another case where j less than or would be enough here. See, I never did this. If you have done this before, it would have been easier. Or there will be simpler implementations than this, because I think doing a for loop is much easier than this, I guess. If you're doing a for loop, that's probably definitely easier. See, doing lazy things here is not that easy, for sure. That's why it's like this. Segment, just copy pasting segment is better. But why are we in a hurry? We are not in a hurry, right? We can try to do this too, and it will be a win. Trying to implement such a thing is good sometimes. So if this has to be updated, we have to handle that. So this is the first segment. I have x here. I cannot use the same value of x. So this is not too complicated. For the first segment, if it existed, and if it needs to be updated, you're updating it now. Okay. And then you're changing the values to your new x, whatever the new x is. This is some old update that needs to be done. You're doing it now lazily. And now, because you're updating that segment, you're trying to make update as -1, update of add x as -1, and then this is just updating that segment. Okay. So let's make things simpler. What should we do to update a segment? If else, what should we do? I'll just use this. This is this segment, right? Starts from idx into rn, can go to plus rn until n. A of I will be x. Sum of idx can be 0, and then sum of idx will be done. And then update of idx will be -1. So having this simplifies things, I guess. Update seg. So now what can we do? Now, now we can do simple, everything simple. So while accessing j, while accessing a of j, because sum should be updated. Update j by rn. It only works first time because once it become -1, we just return. So we are updating before accessing the values. Okay, so this has been updated first time. Whenever we are trying to touch that segment, we have updated that. Now we are updating some because we are changing it further. Okay, this we need not worry about because we are updating the whole segment. We need not worry about. Just doing this two is enough. Here again, because you are changing that things, you can just do this. Even here, you need not worry about update. You can just this works. Need not think. Just this works. Even here we can use it, but we are making sure that whenever you update the whole segment, you're updating its sum. Otherwise, we need not worry about this too. We can add update seg here too. We need not add this. It will still work, but I'm just adding it for no reason. So is this done now? Are we good now? Mr. Raindrop falling away from me now. Fuck! Is screen not visible? Say you're seeing. Say you're seeing. Say you got a girl. I'm just joking. So now, okay. So I just kept updates like everywhere. It's not. We need not keep it here. If we have this sum here, if we have sum, we need not keep that here. But I just kept it for no reason because not thinking is good for us, right? So I just kept them randomly at all places. I'm just a flower on a tree. Why must you live? Here we are setting the update, so we need not again update the previous thing if it is there because we are anyway changing it whole. And it might have gotten updated here itself. Things might have gotten updated here itself because both of them are same things. We need not update here too. Once we reach here, the previous updates might have already been done, right? All of the segments have been updated, so we can just update the final new sum. We need not worry about anything. Still, I'm just a flower on a tree. Still, but then we are getting wrong answer now. Why? This also has passed, but here we are getting wrong answer. Why? One, 2, 3, 4, 5, 6, 7. Would it be because of some reason? Mr. Raindrop falling away from me now. Dun, 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 dun. So, have you guys seen this update seg and these things? And then, because all of the segments have been updated, now I'm just changing the values. While finding some, we have updated them anyway. Let me print the values, okay? Let me print the values. So, what are we doing wrong? 4 to 6 have been updated. Why is this? Okay. 3, 10, 40, 0, 1, 1, 2, 3, 4 to 5 to 6 has been updated. Right. We did that correct. And then 5 to 7 has been updated. 5, 6, 7 has been updated. Right. We did that correct. And then 1 to 6 has been updated. Right. Again, we did that correct. Because plus, uh, if you see 4 threes, 120, it's 4 thirties. What is the sum? 120 plus 60 is 180 plus 30 is 210. 210 by 6. 210 by 6. It has a factor of 5 and 7. So that's also right. And then 3 to 7. Wait, it's passing now. Then why is it failing? I'm just a flower on a tree. Ah, okay, it's failing, it's failing, it's failing. I get it, I get it, I get it, I get it. Mr. Raindrop falling away from me now. We shouldn't slack at the end. We should be careful. Anytime before you access, you update that seg. So would this work now, people? So don't see. Now what's the advantage? Now what's the advantage? You guys will not get scared of enroute and simple things now because you have seen it all. It's like not having any other work, I guess. So because you have seen how enroute can be done so simply, like just having one update segment will make lazy things much easier, much easier. See, this is a simple code. It doesn't look too complicated. So now if I have to implement this again, I will do it much quicker, right? I have never done this before. See, we face TLEs. Maybe it's n log n. Mr. Raindrop falling away from me now. Let's check. Fuck. But Enruten won't work on this thing. Is it because of segmentary lazy? Range update, range query. We have this segmentary lazy. So lazy is doing plus. I should just change the value because it's update, right? It's not adding. It's not adding. It's update. Maybe to -1 because we don't add -1. And then update is also not update, right? We have to change it. We have to change it. Pushing things lazily down. What is this? Segmentary sum or max? It's segmentary min. We need sum. I think we don't need build. I don't know if I can update that segmentary. See, this should work. Endurance should be fine. Wrong answer. I'm just a flower on a tree. Why must you leave? Updating here is bad. This is bad. That shouldn't be done. This is good. Because if you are updating here, you can have something. Big update, big sum. Big update, big sum. Big update, big sum. And at each step, we cannot keep updating it again and again and again, right? Updating here is fine. Doing to routen is fine. Doing n routen is wrong. Doing n routen is bad. So here we are setting update, we are setting the sum. I initially had this. I unnecessarily removed this and then I have added it here, thinking no logic. But then we shouldn't do that. I'm just a flower on a tree. Why must you- We have so many wrong answers. Somewhere in the universe, somewhere someone got it was. Is that many? World's smallest violin. really needs an audience. So if I do not find somebody soon, I broke up into fabulous and spuma turning symphony. All up and down a shady street, my plan up in my mind is like finishing this my life. Still stuck in necessity. This could be the devil, or maybe just a vanity. We are having an assumption that X will always be positive, right? That's why I'm making this. We have that assumption that X is always positive because we are using that assumption in update. So whenever we update, it should be positive. I'll blow up into smithereens and spew my tiny symphony all up and down a city street while trying to put my mind is not finishing this melody. So that's it. We are good now. Whenever A of I is getting updated, it gets updated to positive values and it's fine. To whoever said I will take another I will take someone who the fuck told that I will take another 1 hour for this thing? Where was that? Another 1 hour. Here we go. I don't think it's going another 1 hour. AC people, AC. So guys, should we try G? Problem is simple. Even nroot works. Simple code. See how small is the code. Three segments, three segments. It's same as brute force code that I wrote initially. Should I try this one? It would be much difficult, I guess. I'm scared. But these problems won't be that great. So let's try to get back to our great problems, okay? So we are ending the stream now. Are you lonely? I'll be the only dream you say. So if you're lonely, I'm thinking to not work out today. In the evening, I will try to, but I'm thinking to not. Maybe I have to go out, right, instead of working out. So I'm ending this stream, guys. Be ready to join the next stream, okay? Be ready. It will start in 2 minutes.